Hello everyone. In this video, we shall discuss operations on functions. So what are these operations on functions? Let us consider first two functions, y equals f of x and y is equal to g of x. So we shall define the following operations on the two functions given. So first, we have the sum of two functions and we denote it by f plus g of x. And this is equal to the sum of f of x and g of x. So similarly, if we're going to get the difference between the two functions f and g, and this one is read as f minus g of x, and it is equal to the difference of f of x and g of x. The third one is the product of two functions, and it is denoted by f times g of x, and it is equal to the product of f of x and g of x. And then we have the quotient of two functions, f and g, and it is denoted by f over g of x, and it is equal to the quotient of f of x and g of x. But of course, since g of x is in the denominator, we restrict that g of x is not equal to 0. So here are some examples on evaluating these operations. So for example, if f of x is equal to the function 5x minus 3 and g of x is equal to x squared minus 4x plus 8, let us determine f plus g of x. So by definition, f plus g of x is equal to the sum of f of x and g of x. So which means that we have the following formula. And then we will replace f of x here by 5x minus 3. And g of x will be replaced by x squared minus 4x plus 8. So in other words, we will just add these two functions. So adding them, we get 5x minus 3 plus the quantity of x squared minus 4x plus 8. So adding the similar terms in the following, we will get x squared plus 5x and then minus 4x and then we have minus 3 and then we have plus 8. So we can combine 5x minus 4x and we can combine negative 3 plus 8. So this gives us x squared plus x plus 5. So because 5x minus 4x is positive x and negative 3 plus 8 is positive 5. So this is f plus g of x. Next is, let's consider this time f of x is equal to 5x minus 3, g of x is x squared minus 4x plus 8, but we will determine the value of f minus g of 5. So in this case, no, by definition of the difference of two functions, we can write this as f of 5 minus g of 5. So which means that in the solution, we need to evaluate the function f using x equals 5, and we will evaluate the function g using x equals 5. So for our solution, f of 5 will be 5 times 5 minus 3, which is equal to 25 minus 3, which is equal to 22. And then we will evaluate g using x equals 5, and then we substitute it here, so we get 5 squared minus 4 times 5 plus 8, and that gives us 25 minus 20 plus 8, which is equal to 13. And then, since we already have f of 5 and g of 5, we just plug in those values here, and we get 22 minus 13, which is equal to 9. So the value of f minus g of 5 is equal to positive 9. Next is, let's consider f of x equals 3x squared plus 5 and g of x is equal to negative 3x plus 7. Now this time, let's evaluate f minus g of b minus 4. So as you can see here, the value of x is an expression equivalent to b minus 4. So in here, we shall write f of f minus g of x as um, f of x minus g of x. Sorry for this error. This should be minus sign. So plugging in f of x, which is 3x squared plus 5 here, and then g of x will be replaced by 3x squared, negative 3x plus 7. And then distributing the negative sign here, we get 3x squared plus 5, and then plus 3x, and then minus 7. So adding like terms here, we get 3x squared plus 3x minus 2. So the minus 2 came from positive 5 minus 7. And then, since we're looking for f minus g of b minus 4, this means that every occurrence of x in this particular function shall be replaced by b minus 4. So which means f minus g of b minus 4 will be equal to 3, and then the x here will be replaced by b minus 4. So which means that we're going to apply the square of this binomial plus 3 times x, which will be replaced by b minus 4, and then we have minus 2. Now, if you recall, this in the square of the binomial, so if we have something like x minus y quantity squared, this is equal to x squared minus 2 times x plus times y plus y squared. So applying this formula here, we will get 3 times the quantity of b squared minus 8b plus 16. So we got this because we're going to square b, which is b squared, and then we're going to multiply b and negative 4, which is negative 4b, but there's a times 2 in the formula, so it's going to be negative 8b. And then the square of 4 is 16. And then the positive 3 here will be distributed to b minus 4. So that's why we have here plus 3b and minus 12. And then we write the minus 2. And then the 3 will be here. No, the 3 here will be distributed to b squared minus 8b plus 16. So we will get 3b squared minus 24b plus 48. And then we rewrite the following here. And then adding similar terms, we will get 3b squared minus 21b plus 34. So the minus 21b will come from negative 24b plus 3b. And the 34 here comes from 48 minus 12 minus 2. So this is the value of f minus g of b minus 4. Okay, next is, let's consider this time f of x is equal to 4x squared minus 25. G of x is equal to 4x minus 5. And another function, h of x equals 2x squared minus x minus 15. So let's determine f times g of x and f over g of x. So for our solution, let's solve for f times g of x first. So by definition, f times g of x is defined as f of x times g of x. So we shall replace f of x here by 4x squared minus 25. And then g of x will be replaced by 4x minus 5. So multiplying these two expressions, so will give us 4x squared times 4x is 16x cubed. 4x squared times negative 5 is negative 20x squared. Negative 25 times positive 4x is negative 100x. And then negative 25 times negative 5 is positive 125. So this is f times g of x. Okay, now so since in this solution we have h in the denominator, so there must be a correction here. So this must be h. So that's the reason why we have a function h here. So f divided by h of x, by definition, is f of x over h of x. So plugging in 4x squared minus 25 for f of x and 2x squared minus x minus 15 for h of x, we get the following. But we have to check if there could be some factors that may be canceled out from the numerator and the denominator. So that's why we need to factor in the numerator and in the denominator. So the numerator here is a difference of two squares. So it can be factored as 2x plus 5 times 2x minus 5, while the denominator can be factored as 2x times x. And then we have uh, minus 3 and then plus 5 here. So we check the 2x times x is 2x squared. 5 times negative 3 is negative 15. 2x times negative 3 is negative 6x plus 5x here. That's going to be negative x. So these are the correct factors. So notice that we can cancel out the 2x plus 5. And then we get just 2x minus 5 over x minus 3. Okay, so let's have another example. Let's consider f of x to be square root of 9x minus 2 and g of x is 7 minus x. So let's try to evaluate f times g of 2 and f over g of 3. So first, for f times g of 2, we will evaluate first f of 2. It's because this thing here can be written as f of 2 multiplied by g of 2. So we shall evaluate the function f using x equals 2. So meaning we will replace this by 2. So we get square root of 18 minus 2, which is square root of 16, which is equal to 4. And then we shall evaluate the function g using x equals 2. So we will replace this by 2. So 7 minus 2 is equal to 5. So therefore, f times g of 2 is equal to f of 2 times g of 2, which are equal to 4 and 5. So it's going to be 4 times 5, which is 20. Now for f over g of 3, so we can write this as f of 3 over g of 3 by definition. So which means that we're going to evaluate the function f using x equals 3. And this is going to be square root of 25, which is 5. And then g of 3, so when we evaluate g of 3, it's going to be 7 minus 3, which is equal to 4. So therefore, f over g of 3 will be f of 3 over g of 3, which is equal to 5 over 4. Okay, next we have the composition of functions. So this is another operation involving functions. So the composition of the functions f and g is denoted by this symbol. So this is f circle g, which tells us it is the composition of f and g. And it is defined as follows. F circle g of x can be written as f of g of x. So this means that we need to evaluate g of x first. After evaluating g of x, we are going to evaluate f using the expression g of x. Now, in this case, we replace every occurrence of x in f by g of x. Now, if we define g circle f of x, this is written as g of f of x. And g circle f of x is not necessarily the same as f circle g of x. So let's try to apply this composition of functions. So let's consider f of x to be 3x squared minus 7x plus 12. And g of x is equal to x minus 3. So let's determine f circle g of x. So by definition, f circle g of x is f of g of x. So which means that this thing will be replaced by x minus 3. And then we will evaluate f using this x minus 3. So that means every occurrence of x in the function f will be replaced by x minus 3. So in our solution, we get 3 times the quantity of x minus 3 squared minus 7 times the quantity of x minus 3 plus 12. But we need to expand this. So expanding that binomial, we get x squared minus 6x plus 9. And then distributing these numbers in this negative 7 to x minus 3, we will get the following. So it's 3x squared minus 12x plus 27 minus 7x, and then plus 21 plus 12. And then combining similar terms here, we get 3x squared. And then negative 12x minus 7x is negative 19x. 27 plus 21 plus 12 is equal to 60. So this is f circle g of x. Okay, and then let's have another one. So let f of x be square root of x minus 12 and g of x is 2x plus 3. So by definition, f circle g of x is f of g of x. So this thing should be replaced by 2x plus 3. And then 2x plus 3 will replace the x in the function f. So which means this is going to be the square root of 2x plus 3 minus 12. And that's going to be square root of 2x minus 9. And then for the following item, let f of x be negative 2x squared plus 6x minus 11, and g of x is equal to negative 2x plus 15. So let's evaluate g circle f of 4. So by definition, this g circle f of 4 can be written as g of f of 4. So in our solution, we shall evaluate f of 4 first. So we're going to replace x in the function f by 4. Okay, so the computation is here, and it's equal to negative 2 times 4 squared, which is 16, and then 6 times 4 is 24 minus 11, and then we get negative 32 plus 24 minus 11, which is equal to negative 19. So this negative 19 will replace this f of 4. So thus, we have g of negative 19. And then this negative 19 shall be used to replace the x in the function g. So we have negative 2 times negative 19 plus 15, which is positive 38 plus 15, which is equal to 53. So that ends our video for composition and operations of functions. So I hope that you learned something from this video, and please do not forget to subscribe to my channel. Thank you.